Hi, this is Hilal. In this video on Mathematical Economics series, we will learn how to decompose price effect into substitution effect and income effect using a numerical example. The question is like this. Suppose consumer's utility function is given by u is equal to xy, where x and y are two goods. Price of good X is given as $9 and the price of good Y is $1. And total income of the consumer is also given as $72. Suppose price of good X falls to $4. Originally it was $9 and it fell to $4. We have to find the values of income and substitution effect and the total price effect. Okay, I will try to show it graphically and also algebraically. Okay, so bear with me, it will be a very useful video for you, and if you like this video, then please share this video. Okay, so coming to our business now, what is given here? We are being given a utility function of a consumer. So what is our utility? U is equal to, utility is given as x into y. This is the utility of our consumer. Okay, what is price of x? So we will write here price of x is originally 9, price of y, price of good y is given as 1, and total income, that is m of the consumer, is 72. Okay, this is our original thing that is given to us. Okay, when there is no change in the price of good x. Now what we have to do to find the income effect and substitution effect, we need to find three things, rather three bundles. Okay, first we need to find the initial bundle. Okay, so initial optimal bundle. Second, we have to find the final bundle. Okay, that is the optimal consumption bundle after the change in the price of good X. And lastly, we have to find the decomposition bundle. Okay, so bear with me, I will explain all the things. So these variables are for our initial bundle. First we need to find the initial optimal consumption bundle. That means we need to maximize. So what is the condition for the optimality? For optimality, what we need, first I will write it like this. We need to maximize our utility function, that is u is equal to xy, subject to our budget constraint. Our budget constraint is here, that is a price of x times the units of x plus price of y times units of y should be equal to 72. That means all our income should get exhausted in purchasing bundle 1, that is the x that's what you call that x good and y good. So all our income should get exhausted. Okay, so what is price of x? That is 9. I can write here 9x plus what is the price of good y? That is 1. So I will write here y only. 1 into y is y, should be equal to 72. That means we should exhaust all our income on these two very goods. Okay, now what is the optimality condition for initial bundle? I repeat, I am just first deriving the initial bundle. For that we need the optimality condition. Optimality condition requires what we also call the first order condition or tangency condition. We will use tangency condition here. That is our tangency condition is, now when is our optimal bundle on our indifference curve? So let me draw it here for the sake of understanding. If this denotes x, good x, this is good y, we have a budget constraint. Let us say this is our budget constraint, okay, and we have this indifference curve, that is, let us say this is our u of xy. Now tangency condition requires, this is our indifference curve and this is our budget line, okay, budget line. Tangency condition requires that our budget line and the indifference curve should be tangent to each other. So the tangency point will be this very point, and this will give us the initial bundle. That means at optimal value or for first order condition, our slope of indifference curve should be equal to slope of budget line, okay. Now, what is the slope of indifference curve? It is simply the marginal utility of good x upon marginal utility of good y, okay, and it's negative. And what is the slope of budget line? We know the slope of budget line is equal to ratio of the price of x over price of y, okay. So this condition should hold, and since both are negative, so we have this negative sign here. That means our, and we can just if we take absolute, that means we take only positive values for the sake of simplicity. That means marginal utility of good x upon marginal utility of good y should be equal to ratio of the prices, that is price of x upon price of y. This is our tangency condition. So consumer will purchase at that point where it is indifference curve is tangent to the budget line, okay, or marginal rate of substitution is equal to the ratio of the price line. This marginal utility of x upon marginal utility of y is also called the marginal rate of substitution, okay. Now what is marginal utility of x? Now marginal utility of x means we have to differentiate our utility function partially with respect to x. Now that means du upon dx. What is du upon dx? That partial derivative of this very function. So the derivative of x would be 1, so we are left with y, okay. What is marginal utility of y? That means du upon dy. That means partially differentiating this utility function with respect to y. The derivative of y will be 1, so we are left with x, okay. So marginal utility of x is y, marginal utility of y is x, okay. So using these very things here, so what we have, that means in place of mux I can write y upon x should be equal to, what is price of x? Price of x is 9. And what is price of y? Price of y is 1. When solving, this becomes y into 1 is y, so y is equal to 9x, okay. Now we just need to plug this y is equal to 9x in our budget constraint. This is our budget constraint, okay. Just plug this value to get the optimal values of x and y. So we put this value here, so y is equal to 9x. We have 9x here, so I will write 9x plus the value of y is 9x, so this is 9x is equal to 72, or 9x and 9x is equal to 18x is equal to 72, which implies our x is equal to 72 upon 18, which means 72 upon 18 is equal to 4, okay. So optimal consumption of good x would be 4 initially. Now what will be the optimal consumption of good y? Just plug x is equal to 4 again in our budget constraint. So we have 9 here, 9. In place of x we have 4, so I will write here 4 plus y is equal to 72, or this comes out to be 9 4s are 36 plus y is equal to 72, which means y is equal to 72 minus 36, which comes out to be 36. That means initially our optimal bundle would be that x is equal to 4 units and y is equal to 36 units. Okay, this is our initial bundle rather. Now what we need to find? Now we need to find the final bundle. Okay, final bundle. How do we find the final bundle? Let me draw this line here. Now coming to the second part about finding the final bundle. For finding the final consumption bundle, we have to see the change in the price. Okay, so for final bundle, I will write our utility function will remain same. That is, we have to maximize our this utility function u is equal to xy. Okay, what will be our new budget line? Okay, after the price change, we have price of x will be this time in place of 9, since it tells us that price of x is falls to 4. So price of x is 4, price of y is same, which is given us 1, and budget, that is m, is also 72. Okay, we need to find the optimality condition using these variables here. So first we need to satisfy the tangency condition. Okay, so tangency condition is that slope of indifference curve should be equal to slope of budget line. Okay, so I will write here tangency condition requires tangency condition will remain same. That means marginal utility of x upon marginal utility of y should be equal to price of x. Let us denote it by p star. Okay, p star, this is our new price, upon py. It is same because it has not, price of good y has not changed. Now what is the marginal utility of x? So we have same in utility function, we have calculated marginal utility of x is y. So I will write here y upon what is marginal utility of y? We have calculated, it is x. Okay, should be equal to what is our new price? New price is 4. So I will write here 4 upon what is the price of good y? That is y, sorry, 1. Now just rearranging, we have y should be equal to 4x. Okay, now we just need to plug this y is equal to 4x in our budget constraint. And I am sorry, I forget to write here budget constraint. Now new budget constraint would be like this. Price of x is 4, so this is 4 times x plus y should be equal to 72. Okay, we just need to plug this y is equal to 4x in this very but new budget constraint. So y is equal to 4x, so I will write 4x plus, in place of y we have 4x, I will write 4x should be equal to 72. That means 8 x should be equal to 72, which implies x should be equal to 72 upon 8. That is 8 tens are 80, 8 nines are 72. So we are left with x is equal to 9. That is our optimal consumption bundle after the price change will be x is equal to 9 units. And what will be the value of y? So just plug x is equal to 9 back in our new budget constraint. So we have 4 times the value of x is 9 plus y should be equal to 72. So this comes out to be 9 fours are 36 plus y is equal to 72, or y is equal to, now if we transpose this 72 here, this will become minus 36. So 72 minus 36 becomes 36. Okay, so our new consumption bundle will be let me write it somewhere here to save space also. So new consumption bundle will be X star is equal to 9 and Y star is equal to 36. Okay, rather this is Y. So this is our final bundle, consumption bundle. This is our initial or original consumption bundle. Okay, now what we need to find, we need to find the decomposition bundle. Okay, how do we find the decomposition bundle? Let me, should I rub this out? Because let me see if I can find the decomposition bundle. I will draw here, I will explain the decomposition bundle on this side, then I will rub this and show the graph of the income and substitution effect. Okay, now we need to find the last one, that is decomposition bundle. Okay, for that I need to draw the graph again. Okay, so bear with me, you will learn it very easily. Now how do we find decomposition bundle? First let me draw the graph here. I will draw the graph again. I am not good at drawing the graph, but I will still try to make it more meaningful. So what was our initial budget line? Let us say our initial budget line was, let me use the proper color here. So let us say this was our initial budget line. Okay, this was our initial budget line, and we draw the indifference curve here also. Let me draw the indifference curve like this. Okay, this is our initial. Let us write, this is good X, good Y. Okay, initially, as I told you, our indifference curve and budget line should be tangent to each other for getting the optimal bundle. So initially our X was 4 units, Y was 30 units. Okay, now after that price of X has decreased. Okay, if price of good X decreases, that means consumer will try to consume more of good X. Okay, and his income will increase, his real income will increase, but nominal income will remain same, that is 72, but real income has increased because the price of good X has decreased. So let us say the consumer has new budget line. So with decrease in the price of X, consumer will be able to purchase more of the good X because it became cheaper. So our new budget line will be like this. Okay, this is our new consumption bundle, sorry, new budget line. And at this new budget line, consumer will try to optimize its consumption bundle, and it happens only when the indifference curve and the new budget line are tangent to each other. Let us say our new consumption bundle was like this. Okay, I am not good enough. Let us say this was our IC2. Okay, so if I try to make out sense here, initially consumer was consuming 36 units of good Y and 4 units of good X. Okay, 4 units of good X. Okay, after it is, after his after what you call here, after the change in the price of X, now consumer, we have calculated here, consumer is able to purchase 9 units of good X. Okay, so consumer is able to purchase 9 units of good X. Okay, and same 30 units 36 units of good Y. Okay, new consumption bundle. Now since we have to find the decomposition bundle, why does this decomposition bundle will be drawn. Okay, so it is on the original indifference curve. Okay, our decomposition bundle will lie on our original indifference curve, which is this green indifference curve. Okay, but it will be tangent to our budget line. Okay, it will be tangent to our budget line with slope of the final budget line. Okay, that means it will look like this. If I just try to reduce the monetary restriction here for the consumer, we will draw another parallel line, okay, such that the slope of this budget line and the new line which we draw have same slope. So let me draw it like this. Okay, as I have told you, I am not good enough to draw these very lines. Okay, so what we have done here, we draw the new decomposition bundle, and this line is this line which we draw, this new budget line. Okay, let us say this is called the Hicksian decomposition line. Okay, it is used to differentiate between the substitution effect and income effect. Okay, and how do we find the decomposition bundle? The decomposition bundle will lie on our original indifference curve, that is on this green indifference curve. Okay, but its slope will remain same as that of the new budget line. That is why we draw this new red line, this section line, parallel to our what you call new budget line. Okay, I hope I am making myself clear. It is as confusing here, but I guess you will get it here. Our decomposition bundle will lie on the same indifference curve. Okay, but the slope will be, or it will be tangent to our same indifference curve, but its slope will be same as that of the new budget line. Okay, let us say this is the point where they are tangent to each other. Okay, we have to find out this very point. Okay, now how do we find this very point? For that, we need to find the utility. Okay, utility of original indifference curve. So let me write it here. So finding the decomposition bundle, for that we have u is equal to xy. That was our utility. Okay, so how much utility does the consumer get? We just plug the value of x and y in the utility function. So originally we have 4 and 36, so I can write it like this: 4 into 36. It comes out to be, let me write it properly, this comes out to be 4 into 36, which comes out to be 4 6 are 24, 4 3 are 12, 13, 14. Okay, so we have xy is equal to 44, xy is equal to 144. Okay, this is our decomposition bundle. First, that is the utility attained by consuming initial amount of good x and y gives utility of 144. Okay, now what we have to do, we have to find another equation, or we have to use the tangency condition, but using the new budget constraint. That is, using the tangency condition but using the new budget constraint. So we need to find marginal utility of x upon marginal utility of y should be equal to price of good x, which has changed, upon price of y. Okay, so what is marginal utility of x that we have calculated? It comes out to be y upon marginal utility of y. We have calculated, it came out to be x should be equal to price of x, that was 4, upon price of y, that was 1, and if we solve, this will come out to be y is equal to 4x. Okay, we need to solve this equation and this equation. Okay, I hope I am making myself clear up to this now. Now what we need, what we did to find the decomposition bundle, first we need to find the utility attained by the consumer with the initial amount of x and y. So we just plug the value of x and y in our utility function to get the utility. So x into y is equal to 144. Okay, after that we need to find the tangency condition with new budget line. Okay, or with new tangency condition when the price of x is changed. So for that we know that the price of x has changed to 4 and price of y has remained same. Marginal utility of x upon y will remain same. Okay, we use these very two things, that is this utility function and this equation y is equal to 4x, which was formed by equating the marginal utilities with the changing price ratio, new price ratio. Okay, now what we need to do, we just need to substitute y is equal to 4x in this equation. Okay, now substitute y is equal to 4x in this equation. So we have, in place of x I will write x, in place of y I will write 4x should be equal to 144. So this comes out to be 4x square should be equal to 144, or x square is equal to 144 upon 4. This comes out to be 4 3s are 12, we are left with 2, 4 6 are 24, or x square is equal to 36, which implies x will be equal to, if we transpose square, it will become root, so we take positive root, x will come out to be 6. Okay, so we got x is equal to 6. Now if x is equal to 6, what will be y? Y will be equal to, y is equal to 4 into x. What is x? Is 36. 4 x is 6, so 4 into 6 is 24. Okay, now you need to give attention to this thing which I have used here. So what we did here, we found out new what we call this third step, that is decomposition bundle, and we find the consumer will have 6 units of good x and 24 units of 24 units of good y. Okay, so why do we need this very decomposition bundle? It is only used to differentiate between the income effect and the substitution effect. Okay, so what we can say here, the change from this point, the change, let us say this is point A, this is point B, and this is point C. Okay, the change from A to B, the change from point A to B, so this very change and this very change from B to C is our total effect, and I will show what does it mean. Okay, for that I need to recap how do we find the decomposition bundle. Okay, so what we did here to find the decomposition bundle, we just took our utility function. Okay, what was our utility function, and we plugged the initial consumption bundle in the utility function. So we got xy is equal to 144. This was our one equation. After that, what we did, we used the tangency condition. Okay, tangency condition for this very thing. Okay, what was the tangency condition here? That is y upon x should be equal to 4 upon y, that is new price of good x upon price of y should be equal to marginal utility of x upon marginal utility of y. Okay, And after that we formed another equation, that is y is equal to 4x. We substituted this y is equal to 4x in our this function, x y is equal to decomposition function, and from that we got x is equal to 6 and y is equal to 24. Okay, this was how we calculated decomposition bundle. So this Hicksian line is just use it to show the reduction in the monetary restrictions. It does not happen. It is only used to differentiate between the substitution effect and income effect. Now I will draw this graph again to make the things clear. And so what was our initial consumption bundle? X was 4, x was 4, y was 36, and final bundle was x was 9, y was 36, and what was our decomposition bundle? That was uh, x was 6 and y was 24. Okay, I will write it here so that I can rub this out. Now let's draw the graph again. Let me draw here the graph. So we have x on horizontal axis, y on vertical axis. So original budget line was like this. Let us say this is our original budget line. Okay, and our original indifference curve was, let's draw the original indifference curve like this. Let us say this was our original indifference curve. Okay, now when the price of good x has decreased, that means the consumer's real income has increased. Okay, when the price of x falls to 4, that means consumer's real income has increased, though its nominal income remained same, because with the decrease in the price of good x, obviously consumer will feel that x has become cheaper, and it has become cheaper for him, so he can buy more of good x. Okay, so that means his budget line will also change. Okay, let me draw the new budget line by this red color. So the here there will be tilt, but the intercept on y-axis will remain same because the price of good y has not changed. So let's draw the new budget line like this. This is our new budget line. And also now consumer will try to reach to this new budget line at a point where new indifference curve will be tangent to the new budget line. And let's draw this indifference curve like this. Okay, this is our new indifference curve. After that, what we need to find the consumption bundle. How do we find the consumption bundle? For that we need to draw the Hicksian line. Okay, and decomposition bundle will remain on the original indifference curve, on this indifference curve which we draw originally, but its slope will be slope will be of the new budget line. Okay, so let's draw this parallel here. So it is not parallel here, so let it be like this. Let it be like this. It's not getting parallel here, so let us draw it like this. Okay, why do we need this decomposition bundle? It is only used to differentiate between the substitution and income effect. Okay, and it is drawn on the original budget line. Okay, with the slope of the final budget line. Okay, this decomposition bundle will be on the original indifference curve, but the slope will be of the new budget line. Okay, so let us dig this out. So originally consumer was consuming 36 units of good y. Okay, and 4 units of good x. After the change in the price of x, he still consumes 36 units of good y, but the consumer will consume 9 units of good X. Okay, now this is the total effect. This is the total effect. We need to decompose it into income effect and substitution effect. So what is the we have here the tangency condition, because our new budget line which we draw this Hicksian line here, it is tangent to our original budget line. So this point and this point on this axis is our, we have 24 units here and we have 6 units here. Okay, this Hicksian decomposition line is only used to differentiate between the substitution effect and income effect. Okay, that means the consumer's movement from this point to this point, this is called the substitution effect. Okay, and the movement from this point to this point is called the income effect. Okay, income effect. And we need this decomposition bundle to differentiate between the substitution effect and income effect. Okay, so what did we have here? So let us rub this out and see the final result what we have done. So let us write here initial bundle, initial bundle, initial bundle, final bundle, decomposition bundle. Okay, D bundle I will write here. So I will write here decomposition bundle. Okay, initially consumer was having x was 4, x was 4, y was 36. Finally consumer was getting 9 units of good X and same units of good Y. Okay, that is 36. And decomposition bundle, consumer was having 6 units of good X and 24 units of good Y. Okay, this is our final touch to this very question. Now what is the substitution effect here? Okay, so we need to find the what we call substitution effect. So substitution effect will be equal to, that is equal to the decomposition bundle of good X minus the initial budget line. Okay, initial bundle. So I will write here decomposition bundle minus initial bundle. Okay, so what is the decomposition bundle? It was 6 minus 4, which comes out to be 2. That means our substitution effect will be 2. Okay, that means when the price of good X has fallen, the consumer buys 2 more units of X due to substitution effect. Okay, so what is our income effect? Income effect is equal to that is the final bundle. I will write here final bundle minus the decomposition bundle, that is DB. What is our final bundle? That was 9 minus what was our decomposition bundle? That was 6. Okay, so what does this tell us? What it mean? It means when the price of good X falls, when the price of good X falls, the consumer feels wealthier. Okay, because his real income has changed and he buys 2 more units of sorry, 3, 9 minus 6 is 3 more units of good X. Okay, I hope I make myself clear here. So we just decomposed this substitution effect and income effect here. Okay, so what is price effect or total effect is equal to substitution effect plus income effect. So what is substitution effect? That is 2. What is income effect? That is 3. That means we have total effect of 6. Okay, sorry, 2 plus 3 is equal to 5. That means with the decrease in the price of good X, consumer is able to purchase 5 more units of good X. And uh, this 5 units of good X he purchased, two units are due to the substitution effect, and 3 units are 3 units is due to the income effect here. Okay, and by income effect, what we mean, it is simply when the price of good X falls, the consumer feels wealthier, his real income has increased, and he buys 3 more units of good X. And by substitution effect, it is simply when the price of good X has fallen, consumer buys 2 more units of good X due to substitution effect. Okay, I hope I make myself clear in this video. So let me, if I am able to summarize this whole thing. So what we were given initially we were given the utility u is equal to xy. Okay, price of x was 9, price of y was 1, and total income of the consumer was 72. So we need to find three things: initial bundle, final bundle, and decomposition bundle. So initial bundle is found by when marginal utility of x upon marginal utility of y was equal to the ratio of the price of x upon price of x. Marginal utility of x was differentiating this thing, we get y. Marginal utility of y differentiating with respect to y, we get x should be equal to price of x upon y, that is 9 upon 1. So y was equal to 9x. And after that, what we did initially, we found that our original budget constraint was like this, that was 9x plus y was equal to 72. Okay, we just plugged this y is equal to 9x here, and we found x is equal to 4. After that, we again put x is equal to 4 in this, and we got y is equal to 36. Okay, this was for the initial bundle. For the final bundle, what we need, we were given the utility function u is equal to xy. Okay, and our new budget constraint was, because the price of x has fallen to 4 in place of 9, we were here having only 4x plus y should have been equal to 72. Using the tangency condition here, again marginal utility of x upon marginal utility of y should have been equal to ratio of price x, that was the new price upon price of y. And again we got y upon x was equal to 4 upon 1, and that means y was equal to 4x. Okay, we just plug this y is equal to 4x again, this in a new budget constraint. After that, we got x is equal to 9 and y is equal to 36. Okay, after that, what we need to find, we have to find the decomposition bundle. So how do we calculate the decomposition bundle? We just take our original utility function, that is u is equal to xy, and in this we put the value of original initial consumption bundle, that was 4 and 36. So y was 4 into 36, so 4 into 36 was 144. So xy was equal to 144. Okay, okay, क्या छ गोलो थास ukun halas isna papa isna our. So we just took this xy was equal to 144. After that, we used our new budget constraint here. Our new budget constraint was that marginal utility of x upon marginal utility of y should have been equal to our new price ratio, that was price of x upon price of y. Okay, marginal utility of x and y was y upon x, and our this ratio was 4 upon, we have calculated here 4 upon 1. So we got y is equal to 4x. After that, what we did, we solved this equation and these two equations, and we got our consumption bundle uh, decomposition bundle was, when we plug y is equal to 4x in this, we got y is equal to 24 and x was 6. Okay, sorry, x was 6. And after that we just compared these very things to get our substitution effect and income effect. I hope I make myself clear in this video. Thank you.